Yeah. Good evening. Good evening, everybody. Good evening, online students. So the topic is operations on 1D array. Suppose you have created a one-dimensional array of size. Let us take a bigger size, little bigger size. 4, 6, 2, 9, 3. This is an array of array of size 8 I have taken, and I have taken just 7 elements so that I can discuss various operations. So now what are the operations that we are going to discuss? First is insert, second is delete, third one is find, fourth one is search. Under this you have linear search, binary search, then there is something called as sort, then reverse, is sorted, sorted, insert. One more primary operation, traverse. Traverse. You can take the list. We will discuss all these operations and also the time complexities of these operations. Now, one important thing is traverse, insert, delete, find, or search. This I have listed. These are the operations that are performed upon collection of objects. You have collection of objects, in that you are inserting one object or deleting the object, or you are searching for an object, or you are visiting all the objects, going through all the objects once. If you have any collection of objects, then these are the common operations performed upon the collection. You agree with this? You have collection of books. You brought a new book and you are adding to collection. One book you are giving it to your friend, so you are taking out a book, deleting a book, and you are searching for a book. So this type of operations, and you are just going through what are the books you have in your shelf. So these are the common operations performed on the collection of objects. Now, what is data structure? Organizing collection of data only. Collection of data. All right, collection of data, so that it can be efficiently utilized by the application or your program. So data structure is a collection of objects, you can say now. Organizing data, that is organizing collection of objects. So let us make it short. It is a collection of objects. So what all the data structure you are going to study on those data structure, these are the common operations. Traversing, inserting, deleting, and searching or finding. These are the common operation on all. And depending on the data structure, you may have more operations upon them. All right. Data structure upon any data structure, these are the common operation. In a tree also you'll insert and delete, in a graph also you'll insert and delete, and traverse, and a stack also you'll insert and delete, queue also, hashing also. In all the data structure, these are the common operations. All right, is it clear? Now let us start. So first thing is traversing an array. If you have an array of size 8, I have taken an array of size 8 and I have taken just 7 elements intentionally, just kept left one empty so that I can show you other operations on this one. Now, first operation is traverse. Traversing means visiting all the elements once. Visiting all the elements once. Traverse. So for visiting all the elements, as you can access an array with the help of an index, so you can take one index, let us say I, so integer I. I'm writing a C language or pseudocode, you can say. Now, this I is initially at 0 and I is less than whatever the size is how much? 8 here, so let us call the size as n, then I plus plus. Printf percentile d a of I. So using a for loop, you can traverse an entire array. Now right now you have, if you want to define n also, then you can take it here. N is how much? You have how many elements? 7 elements. Right now you have 7 elements. The size of the array is 7. Sorry. Size of the array is 8. Let us call it like this. Length is how much? 7. Size is the capacity of the array. Length is the length of the list of elements in it. So size and length gives the same idea, same sense, but let us differentiate. Size means the size of the array is the capacity and length is the number of elements. So n is the length of an array, the number of elements right now. So by using a for loop, we can traverse the array. So when you are using a for loop, this I starts from 0, then it will go on 1, then it will go on 2. So in this way, it will go on moving, and every element you are going to print. So how many elements you will be visiting in this way using for loop? 7 elements. And if we call them as whatever the number of elements it is having, let us call it as n elements it is having. So then how much time it is taking? How much work you are doing? N number of elements you are printing. N number of elements you are printing. So what is the amount of work you are doing? N amount of work you are doing. So the time complexity of this one is how much? Out of n. Time is O of n. All right. So whether you say big O, omega, what you say, that is a different thing. That's a different discussion. So let us call it as order of, so O of n. So as if you see the amount of work done, printing one element is 1. Printing n element is 1 into n. So it is n, order of n. So this is the code for traversing an array from left to right in this direction. Can you traverse in the backward direction also? Yes, you can traverse in the backward direction also. So traversing, you can note down this one, then we'll move further. Zero. How many elements we have stored? Size is 8. You may be declaring an array of size 10, but you are storing only 4 elements initially. Later on, you will be adding more elements to it. आपका शेल्फ का साइज कितना है और बुक्स अब कितने हैं, ऐसा. Over. Now, if you want to traverse this array backward, then the method is you have to again use a for loop, but this time I will not be starting from here. I will be starting from this place. So for I assign, come on, oh, sorry, I will be starting from, I will be starting from this place. So what's that? I assign n minus 1. I is greater than or equal to 0 also, and I minus minus, it will be decrementing, and you can print f percentile d a of I. So this will be printing all the elements from backward, last element towards first element, in the reverse. It will print them in reverse. The time taken for traversing backward is also O of n. Now, important thing. Traversing doesn't mean printing all of them. Doesn't mean printing. Traversing means visiting all the elements. Now, by visiting, what you want to do? By visiting all of them, what you want to do? I want to print them. Okay, printed. Now, by visiting, what you want to do? I want to count them. Okay, count them. By visiting, what do you want to do? By visiting, I want to look for a particular element, that is searching. So you can find out an element. Once the element is found, you can stop. By visiting, what do you want to do? I want to see how many times a particular element is appearing. Occurrences of a particular element, how many times it's appearing. So you can count it. Wherever it is found, you can go on to counting it. So traversing means visiting all the elements in a data structure, in any data structure. So it's a common operation. Now, basic thing is you should know how to traverse on any data structure. If you know how to traverse, then you can perform all the algorithms, all the operations on that data structure. So the basic operation is traversing. You should know how to traverse. So on an array, you can traverse in this direction or either in this direction, forward direction or backward direction. That may not be possible in every data structure. So on array, it is possible. And how much the time it is taking, it's order of n. Order of n. Order of n makes a sense that the time taken is linear. Linear. Time is linear. And array is also linear. Array is linear. So the time taken is linear. All right. So now based on this traverse only, we'll be performing all these operations. So let us look at the next operation now. Next operation is insert. Listen. Inserting an element. Inserting an element in an existing array. So first of all, there should be free space available in an array. Then only you can insert a new element. So what do you want to insert? I want to insert a value 10. Okay. So the value that 10 I want to insert. Now the next thing is where you want to insert. That's also a question. So at what index you want to insert. That's also a question. So at index 3, I want to insert it. Means at this place. At this place, I want to insert. All right. Now, inserting means what? Will I remove 9 and write down 10 there? If I am doing that, I am updating the value there. I'm updating it. Inserting means what? Making a free space and inserting 10 in between. So how the array should look like? 4, 6, 2, 10, then 9, 3, 7, 5. So there should be an extra space available. Yes, we have an extra space available here, but 10 cannot come directly here. So for that, what we have to do? We have to shift all the elements first. So first of all, okay, for shifting all the elements, we must take a index starting from here. How we should shift them? From this side or from end? How to shift the elements? From last. From last, we should shift the elements. So we should start from the last element. All right. After going to the last element, shift these elements. First, shift this 5. Okay. Then move this I here. Decrement I. Then shift this element O. Shift 7. Then shift decrement I. Then shift 3. Then decrement I. Then shift 9. That's all. Have we reached at that index 3? Yes. So first I have to shift all the elements until I reach that index. Then I can write down the value 10 here. All right. So tell me what is the code for inserting an element at this place? Okay, I am writing pseudocode. I may not be declaring the things every time. I may not be declaring. You know the variable declaration, everything is required. Just a piece of code. So for I assign what? N. You know N. Okay. Shall we take it as length instead of N? Shall we take it as length? Yes. We will take it as length minus 1. Right? I assign length minus 1. And I is, come on. At which index? 3. So till there we have to move the elements, keep on moving the elements. So shall I say greater than or equal to what? Index. Greater than or equal to index, and I should say I minus minus. Now initially I started at 6. We started at 6, right? So what we have to do? We have to move the element to the next place. So tell me the code what I have to write down. A of next place, you should copy the element from current place. Current place. This will shift all the elements. Now once this is inside the for loop, once it is done, once you come out, now all the elements are shifted and I is pointing at the place where you want to insert an element. Then what you should do? A of I, or you can also say index, or also you can use I, because both are there only now. Assign what? The value 10 that you wanted to insert, X. Then after that, you should also do one more thing. What is that? Length plus plus. You should also modify the length. Now length was 7, now it should become 8. Alright, is it clear? That's it. Now one more thing. You should also check edge cases also before insertion. Edge cases you must check. But mostly in GATE, they don't focus on edge cases. Though they don't give the questions by considering edge cases also. Like in when you are doing proper programming, then you have to take care of edge cases also. What is this edge case? Let us see. The index, what was the length of this? 7. Now that index should be within that length 7 only. That is from 0 to 6. No, 6. Last is 6. 0 to 6. Length was 7. Number of elements were 7. The last index should be from 0 to 6 only. If it is more than that, or more than, if it is, it should be, 0 to 7, 0 to 7 last. And if it is more than that, then you cannot insert any element. All right. So take down this one. We are not checking those edge cases here. I'm not checking the case whether the index is given valid or not. I'm not checking it. Length is? Yes. Out of bounds, yes. We'll consider it out of bound. So this element 10 is inserted here. For loop equal to? Right. See, size of an array is 8. We were having 7 elements. So 7 minus 1. We started from index 6 onwards. क्लियर नहीं हुआ? I need space here, so I'm just moving it. 9, 3, 7, 5. All right. Let us start once again. 9, 3. These are the elements we have. Total how many elements we have? 7. So I have taken that in length. You can also call this as n as 7. So total 7 elements I have. All right. If I want to insert a new element, what are the positions available? I can insert a new element at 0, 1, 2, 3, 4, 5, 6, as well as at 7. I can insert a new element at 7 also. There is a free space. So the allowed spaces are from 0 to 7. So what is 7? 7 is nothing but length minus 1. No, just length. 0 to, not minus 1, 0 to length. 0 to length. Length is 7. I can insert a new element at the last also. What do you call to an operation if you are just inserting a new element at the end of an array? Listen, if you are just adding a new element here at the end of an array, then we call it as what? Append. At the end of the list. If you are inserting at any other place, we can say insert. If you are inserting at the last also, we can say insert. But you can call it with a special name, that is append. Append. Just append it to an array. Append means adding one element at the end of an array. साइज नहीं यार, साइज और इसमें क्या प्रॉब्लम हो गया है? नहीं, what is the size of the array? 8. How many elements you have? Both are same? No. Now tell me what I should call to this size of the array. No, variable name. No. I want to declare the length of an array in some variable. Shall I call it as n equal to 8? What I should call it as? क्या पुकारूं उसको मैं? लेंथ को क्या? साइज को क्या बोलूंगा? Size is different. Number of elements are different. Two different things are there. I can have one array just one element. Now what is the array size? गिनते रह जाओगे. हाँ. But how many elements are there? When I want to insert a new element, so what I am concerned about? The size of this entire array or just how many elements are there present here? Number of elements present here, not the size of the array. So can I insert a new element here at this place? Can I insert an element and it will be a part of a list of elements? Will it be a part of a list of elements? ये लिस्ट में आया क्या? कैसा आया? अरे नहीं, अरे एक मिनट. You don't think over. Okay, just listen carefully. This is an array. Okay, this is an array. And 2 is the list of elements. So how many elements are in your list right now? 1 element. Shall I add 8 here and say it's a part of a list? 2 or 8 are forming a list. List मतलब कहाँ होना? Next element, where it should be. Array में मैं कहीं भी लिख सकता हूँ, वो बात नहीं हो रही है. You can write an element anywhere in an array. But will it be a part of a list? No. So where it should be? Next place. हाँ. आया समझ में आया नहीं आया? I want to write 10. Where I should write next element? And anywhere we will write. अच्छा, अगर anywhere लिखें तो अब वो कोई meaning है? If it is somewhere else, there is no meaning in that. So it should be next to this one. So this is forming a list of elements. So now what is the size of your list now? Size of the list is 3. Is it clear? Size of the list is 3. So you have 3 elements in this one. Understood this or not? Size of the array is different. That is the capacity. That's the capacity. And what is the size of the list? Size of the list is 3 here. Understood? Is it clear now? So you have the list of element present inside an array. So if they are written here and there, it will not we will not call it as a list. अब मैं list of student लिखता हूं मैं, अजय, विनय, लिस्ट है ये. फिर तो लिस्ट मतलब उसके नीचे आना ना विनय, उसके बाद राज. नहीं सर बोर्ड पे इतनी जगह है, कहीं भी लिखो ना, वहीं क्यों लिख रहे हो? सो लिस्ट मीन्स इट शुड बी कंटिन्यूअस ना. आगे समझ में आ गया? नहीं आ गया? हाँ. नहीं, मैं पूछता हूं तो आप लोग क्विक आंसर, रॉन्ग आंसर देते हो, और एक रॉन्ग आंसर देता है तो सभी सब उसके साथ बोलते हो हाँ हाँ सही है सही है. तो उसमें समझाना पड़ता है. तो एक काम करूंगा, मैं पूछूंगा ही नहीं, मैं आई नॉट आस्क. सो नाउ बैक, द कैपेसिटी ऑफ एन अरे. What this? We should know what is the capacity of the array also, so that we can insert the element. We should not go beyond the capacity of an array. So for that, I have given the name of this variable as not n. I have given the name of this variable as what? Size is how much? 8. So this array capacity is 8. It can hold maximum 8 elements. List of size 8 elements. Is it clear? Now, how many elements I am having in the list right now? I have only 7 elements. I'm not talking about the index. 1, 2, 3, 4, 5, 6, 7 elements I have. So I should know what is the list of elements right now present in the array also. So for that, I have given the name as what? Length. Length as how much? 7. Length is 7. You call it as length or n, whatever it is. But n means is a general word. It can be used as a size of an array also and the size of a list also. So I'm not using n here. All right. It's a general word, letter used. So I have given the separate name. Size of an array is 8. It can hold a list of size 8. Right now, how many elements are there in an array? In a list, there are only 7 elements. All right. Now, next, we'll move further. If you want to insert a new element at this place, then this operation is called as append. At which place I am inserting? At last place, that is 7. So what is that 7? That is equal to length right now. All right. So what are the valid indexes at which I can insert an element? From 0 to length, 7. 0 to 7. I can insert at any place from 0 to 7. If I am inserting at this place, it is called as append. Now, will this piece of code insert a new element at index 7 or not? Let us check it. Let us check it. I want to insert a new value 10 at index 7. At index 7. All right. So first I assign length minus 1. I assign length minus 1. That is what? 6. Now I assign length minus 1. So now I is greater than or equal to index. Index is what? No. Index is 7. I want to insert as index 7. Now I, is it greater than or equal? No, it is smaller. Neither equal, not greater, smaller. So will it enter inside this for loop? No. So it comes out and say a of index assign x. So at which index you want to insert? This one. So it will insert the element 10. It will insert the element 10. And now length should become how much? Length should become, so this should become how much? 8. This should become 8. Now length is equal to size. I cannot insert more elements right now. All right. So in the edge cases, you should also check whether length has become equal to size. Otherwise, you should not allow it. If it has become equal, we should not allow to insert. All right. When you are writing a complete program, then you should take care of these. So in GATE, you will, without writing a complete program, even he will not give you a code for writing a complete program. All right. So we are not learning complete programming here. Understood this one? So, but I am discussing what are the points you have to take care. Now here, this piece of code will just insert an element at the index you have given. So it's inserting at the last index also. Now you tell me, what is the time taken when I am inserting at the last place? At the last place, how much time it has taken? I was initialized, then for loop executed. No, for loop was not executed. Then just the element was inserted. So how many steps? One step. So the time is how much? Constant. Order of 1. If you are appending or inserting at the last, the time is order of 1. Just wait a minute. Listen. Now, now I want to insert a value 10 at index 2. At index 2. When I want to insert an element at index 2, then what I have to do? I should start I from length minus 1 as per this code, what we have written, length minus 1. Then as long as it is greater than or equal to index, I should go on shifting the elements. This is shifting the elements. So how many elements are shifted? This 5 is shifted here. 5 is shifted. Then I is decremented. Then 7 is shifted. Right? Then I is decremented. Then 3 is shifted. Then I is decremented. Then 9 is shifted. Then I is decremented. Then 2 is shifted. Over. It stops here. Alright? So I is greater than or equal to this one also. It will shift the element. Then one last thing. Let us follow the code exactly. Till here it has shifted. Then again I minus minus. I will be moving to the previous index and it will stop. Previous index and it will stop. Right? Now it will stop. Then when we have came out, A of index is how much? 2. So A of 2 we will store the value 10. So at this place we will store the value 10. Alright. So for inserting at index 2, we have to shift few elements. Few elements, not all elements. Is it clear till here? Suppose I want to insert a new element at index 0. At index 0. Then I have to shift all the elements. I have to shift all the elements. Is it clear? Now, if I am inserting at index 0, then I should shift all the elements. Then it means I want to insert here. Then what is the time taken for doing this? Order of n. Order of n. This is the piece of code for inserting an element at a given index in an array which is already having length number of elements. Right? So it will insert the element at this side in order of 1 time, insert an element on this side in order of n time. Order of n time. Is it clear? Now, what is the minimum time taken by this one? What is the maximum time taken? Order of n. So if you want to note down this, you can note down, then we will discuss more on this one. I'll clear up this one and explain this part. This code already you have taken, I think. You may have to draw this array every time in your notes. I have drawn it 1 time, but you have to draw it multiple times. Now listen. You have seen insertion. Insertion requires shifting of elements. And the time taken for insertion is dependent on shifting of elements only. Shifting of elements. It depends on the shifting of elements. Now, if I am inserting at this place, the time taken is big O of 1. So the minimum time taken for shifting is O of 1. And if I am shifting at this place, then I have to shift all n elements. So let us say n elements are there, length elements or n elements. So it's taking maximum time, and the maximum time is what? O of n. Now, if I am inserting at index 5, then what? How much time? See, at index 7, it was 1. At index 6, how much? At index 5, how much? All these are constants only. 1, 2, 3, 4, all these are constant only. Right? Constant only. Now, we know what is the time, minimum time taken, what is the maximum time taken. At any other placements, what we should consider? Shall we consider the minimum time or maximum time? No. If at any other place, if we just say insertion take how much time, shall we always say order of 1 or shall we say always big O of, order of n or 1? What we should say? Order of n. Now listen, one important thing. Whenever you talk about the time taken by any operation or any algorithm or any procedure, we usually talk about which time? Maximum time, not the minimum time. Maximum time. Usually talk about the maximum time, not minimum time. In some rare cases, we appreciate the minimum time and we talk about that one. Mostly we talk about maximum time. What is the time taken by say this operation? So we say maximum, not minimum. All right. Now let us consider one thing. Suppose you are inserting at this place, then you said it's 1. At next place, it said you take 2, or 3, 4, goes on up to what? N. Now listen. One important thing. When you want to perform insertion, listen this statement very carefully. When you want to perform insertion, how much time it takes? So in case you are inserting at the last, if you are inserting at the last, the time is 1. And that is the minimum time. So this is best case time. Best case time. Listen once again. Best case time. We are discussing something else here now. All right. So best case time. What is the case? If you are inserting at the last, that is the case. And what is the time of that best case? Order of 1. So this is not best case. This is best case time. What is best case? Inserting at the last. Now once again. If you want to insert an element in an array, and in case if you are inserting in the beginning of an array, at index 0, at very beginning of an array, then the time taken is order of n, and that's the maximum time. And this is the worst case time. And what is the worst case? If you are inserting on the beginning of an array. All right. Now the question is, if you are inserting at index 6, in case you are inserting here at the last place, or in case if you are inserting just 1 before that place, or 1 before that, 2 places before, 3 places before, 4. So these are all cases. Cases or not? Yes. So in case if you are inserting at the last one, if it is here 2, 3, 4, so on, up to what? Last is what? N. So total how many cases you have taken? We have considered all n cases. So divided the time taken by all these cases by number of cases. Listen, the time taken by each case we are adding divided by number of cases. Total time by all cases divided by number of cases. So what is this? This gives was average case. Average case. So this is how much? Wait a minute. This is how much? Nahin. On the top is what? N into n plus 1 by 2 whole divided by n. So this gets cancelled. So this is n plus 1 by 2. I have separated. So is it a polynomial? Polynomial. What is the degree of the polynomial? 1. So order of n. Order of n. So this is also how much? It's also order of, this is also order of n. Now listen, here we have analyzed the time in detail upon insertion only. Now same thing we will do it for all this now. You should keep this in mind. Whenever you are performing operation upon an array, then if it is on this side, this one, if it is on this side, it's order of n, and that side is best case, this side is worst case, and on average also it's n into, n plus 1 by 2, that is nothing but order of n only. Order of n only. All right. Now you write down time taken by insertion, time analysis for insertion, time complexity of insertion. Note down, I have to discuss more on this one. Little more on this one. So time analysis or time complexity of insert. All right. So first you write down best case. Best case. I'm dictating best case. If you are inserting an element at the end of an array on the right hand side, end of a list on the right hand side. If you are inserting an element at the end of a list on the right side, best case you are writing. This is best case. All right, on the right side. End means this is also end, that is also end. So that's why I said right end. Okay, so right side. Now next you write on best case time is big O of 1. Best case time. That was best case. Best case time is big O of 1. All right. Then below that you write down in bracket because we don't have to shift the elements. Because we don't have to shift the elements. Why you are getting order of 1? Because you don't have to shift the elements. Next is worst case. Worst case. Worst case. If you are inserting an element at the beginning of an array, beginning of a list, that is on left side. If you are inserting an element at the beginning of a list, that is on left side. Beginning of a list, that is on left side. This is case. You are defining a case first. Then in that case, what is the time? Worst case. You are writing worst case. Beginning of a list, that is on left side. Then you write down worst case time is big O of n or O order of n, O of n. Big O of n, order of n. So below that you can write down the reason in bracket because we have to shift all n elements in a list. Because we have to shift all n elements in a list. All right. The next is average case. Average case. Average case means find the time taken in all possible cases. Find the total time taken in all possible cases. Find total time taken in all possible cases. If the size of a list is n, then there are n cases. If the size of a list is n, then there are n cases. It means we can insert at n different places. It means we can insert at n different places. All right. Next is average case time is what? Average case time is what? Total time by all cases divided by number of cases. Average case time. Time, you have to write time. Average case time is total time by all cases divided by number of cases. All right. Now, this is the general discussion, not just limited to insert and not just limited to array. It's a general concept for all the data structure. Now you have learned what is best case, what is worst case, and what is average case. You have learned this one. You have learned. So now we are finding average case. Average case is what? So inserting at last position. Okay, the next, before last, second last, third last, fourth last. In this way we are taking and then divided by n. It's order of 1. So average case also, average case is also order of n. Now, listen. For finding best case, identifying best case in this one, was it easy? Was it easy or not? Yes. Finding worst case, was it easy? Yes or no? Worst case on this side. No, see. We know that for insertion, we have to shift the elements. We know very well. Now, when we have this idea, how much time it takes for insertion, based on that, what could be the maximum time? Was it difficult for you to identify which part takes maximum time? No, it was easy. Now, for average time, for finding average time, you have to apply some mathematics here. Some mathematics here. So, which is the difficult part here for finding, which is the difficult time? Average case time. So, always finding average case time is difficult on any data structure for any operation. So, no doubt, here it was not that much difficult. It was easy, sum of first and natural number, and we got it. But this may not be the situation in every data structure for every operation. Listen carefully, listen carefully. This may not be the situation every time. So sometimes we have to involve into complex mathematics for finding the average time for some data structure, some operation. All right. So that is the reason we don't always find average case time. We mostly rely on worst case time. I give you one more general idea here. One more general idea here. Minimum time, minimum case you can identify, max case also you can identify. So we rely on the maximum time. Because if you try to find the max average also, mostly it is observed that that will be similar to worst case only. Worst case only. But if you are feeling that no, average may be less than worst case, much less than, then you do analysis. All right. So if the data structure becomes, for different data structure, that method may be different. It may not be same. Always not n into n plus 1 by 2 always, right? So it is different in different situations. So always finding average case involves a lot of mathematics. Is it clear? So we don't always find average case. Is it clear? Chalo. Over. Now we'll move on to the next operation. Okay, I'll copy this. Will it move? Okay. Two, 9, 3, 7, 5. And this is, we have length of a list is 7. Okay. Length of an array or the size of an array is 8 and the length of a list is 7. We have just 7 elements. We have finished insert operation. Now we'll talk about delete operation. Now we'll talk about delete operation. Here, I want to delete an element from this array. Delete, remove one element from this array. So when you want to delete some element from an array, then you must mention from which index you want to delete an element. Suppose I say I want to delete the element from index 3. Index 3. See, I'm not giving the element, I am giving the index, not element. If I am giving element, you should know where the element is first. So for knowing where the element is, you have to perform search. So we are not talking in terms of the element, we are deciding based on the index. I want to remove the element from index 9. Sorry, index 3. Sorry, index 3. I want to delete this element. So for deleting this element, just you take away this element 9. Take away this element. Now, that place is, you have taken the element, means you have to assume that place is vacant now. That place is vacant now. So when you have taken away this element, this place is vacant. So when this is vacant, now again you cannot have a blank places within a list. List must be continuous, one beside another. So what you have to do now, you have to shift all these elements one by one here. You have to shift all these elements. So after deletion, deletion means take out the element from the place, and that place you have to assume it as vacant, and then you, for filling up that, you should move all the elements. It is just like, suppose 7 members were sitting on one long bench, then one person has gone, he has went out, then you should occupy the place. Then all these people should move this side. Same as that. Okay? Is it clear? Understood this one? Got it? So now you tell me the procedure, what I should write down for doing this one. I want to remove this element from this particular index, assuming that index is valid index. Because what are the indices possible? You have the element length is how much? 7. So you can delete the elements from index 0 to 6 only. 6 only. So we are assuming that valid index is given. We are not checking index is valid or not, error, or throwing an exception. Those things we are not doing. We are just writing a piece of code for shifting the elements. That's all. So first of all, we will take the element from the index into a variable x. So x is now 9. We have taken the element. X is 9. Now what I have to do? I have to shift all the elements. All right. Don't raise any question. Just what I am discussing, just listen carefully. Okay. If you are getting a question, we will discuss about it later. Right. I can read your faces. So whatever the question you are getting, I know what question you are getting. I'll tell it afterwards. All right. So don't think beyond this discussion. All right. Now this place we have to assume it is vacant because the element is gone. So we should shift all the elements. So from where we should start shifting? See, one thing. I can stand at free space and bring the element from there to here. Or else I can stand on that element. Okay, see here. I can stand at this empty place and bring the element on this side. Or else I can stand at this element and I can push the element that side also. Two way I can do. Either way I can do. All right. Both the way it's possible. So if you prefer standing here, now you can bring the elements. All right. Bring the element. So you should stand I at index 3. So this we have to keep on doing it. So let us make it as a for loop. For I assign index onwards. Then how long it should continue, we will decide later. Then I++ definitely we have to do. So then what we have to do, at this A of I, we should copy the element from A of I plus 1. This way we have to move the element. All right. Now, okay, this is index. So it will move 3. Then, okay, I will not move it. So it is taking time. Again, I will decrement, I will increment. So up to which element I should go? Up to last index, what I should stop? Length minus 2 or length minus 1 or length what? Length is how much? 7. This is giving number of elements, not the index of last element, right? Not the index of last element, number of elements. So length minus 2. So if I am shifting like this, okay, so what I'll do is I'll erase this and write down 3 here. And I'll increment I. The next is erase this and copy this 7 here. And then increment I. Then again, copy this 5 here, So this is erased. Now I is moved here. I should stop. I should not do anything. So till what place I have done it? When I was at here, at this place, at 5. When it has gone on 6, I have stopped. So till 5, I was moving it. All right, till 5. So what is that? Length is 7. 7 minus 2. Length minus 2. So I should continue this until length minus 2. And finally, after this, I should also decrement length. So this is length minus. Length should also be decremented. Now you have how many elements? What is the length of a list now? It's 6, not 7. You should change it to this one. 6. Over. That's all. This is the code for deletion. Now how much time this is taking and all, we will discuss after this. First you write down. Now one more thing. One question I am asking. 9 was there when I removed. So that place will become blank. Will it become 0? Programmatically. See, on board, I have shown you that I have erased it. Right? On paper, I have erased it. But inside the memory, will it be gone? No. What will be there then? Same value. 9 will be there. What I wrote? X assign A of index. Okay, right now I want to delete from index 3. So who is there? 3. If I say X assign A of index, so what I'll get? 3 in this variable X. So I got a copy of that value in X. So I am clearing that 3 anywhere here in the code? No. So when I started shifting, that is removed. If I don't shift, the value remains same. Just you have taken a copy. It doesn't mean it is deleted. All right. Now one more last thing. Last value was 5 here. I have copied here. Do you have 5 still there in the memory? Yes, 5 is there. But what is the size of the list now? Right now, 6. So your list stops here. So whatever is there is now for you, it is a garbage. It's a garbage. After that, whatever may be there, it's a garbage for you. Is it clear? Understood this one? Now, if you have any questions, you ask me. Any questions? No. So copy this deletion. Then you will be telling me the time complexity for this. 9 is gone and you are shifting all the elements. So you can draw the original array with 9 here. Then you can draw this array showing 9 is gone. And you are showing the shifting part. If you want to draw it, illustration if you want to draw, you can draw that one. Yes, length minus 2. Yeah, Jaya has given that condition. Yes, online student, you can give your answers when I'm asking questions so that I can understand, I can know how much you're following. Okay, very good. Jaya has asked a question. Okay, I'll answer it. It's better all of you answer it. And mean in that way you can also ask question if you have. Okay. One more question, one more doubt usually arises. I'll ask the question, then I'll also answer it. Finished? Listen. Data structure means collection of elements, collection of data. Library, personal library means collection of books. Okay, collection of books. You brought a new book, purchased a new book, brought it, and you are putting into the collection. It means you are inserting it. Inserting it. Now you want to read one book. You will take out the book from the collection. It means you have deleted the book. You took out the book. It means it's not in the collection now. It is on your desk or in a bag or you have given to your friend. So deletion does it mean throwing away or you need it so that's why you took it out? If you are throwing away, then why did you keep it? Why you are keeping all those throwables with you? So you need it, so you have taken it out. So do you need the book or not? Now I'll ask a question. We are deleting 9. Why we are taking it in X when we are deleting it? Come on. Why we are taking later? We want to use it. Deleting doesn't mean throwing away the element. We want to use the element, so we took it out. Now whether we'll keep it back or not, that's a different thing. Okay, like in the book example, we may want to keep it out or we have given away to our friend, so we are not throwing it, so we are using it anyway. So we keep the elements so that when we need them, we will use them. So deletion also means using. Just traversing means visiting all of them. Deleting means we want to take it out and use it. So that's the reason we have taken. Always for deletion, we will take out the element and keep it in some variable. So it's not throw away, using. All right. This question arises like when you are deleting, why you are taking in X? So This is the piece of code which we are looking at, that's just taking out the value. But after taking out, rest of the program is using it. We are looking at only part of a program. That's all. Now, further, what is the time taken if you are deleting from this side? Come on, deleting from this side. O of 1. Why order of 1? Because you don't have to shift the elements. And the major time for deletion is what? Shifting of the elements only, not just taking the elements, shifting of the elements. So if you are deleting the very first element, how much the time is taken? Order of n. So minimum time is how much? 1. That is from the right hand side. Maximum time is how much? Order of n. That is from the left hand side. And average time is how much? This is same as that. It's how much? Order of n. That is n plus 1 by 2. So the analysis for deletion is also same. Because the similar thing is involved here. That is, you are shifting the elements. Time spent on shifting the elements. There also the time was spent on shifting. Here also time is spent on shifting only. So the analysis is same as that one. So the time taken for deletion. So cases you can write on. Cases are same as insert only. So cases say if you are deleting from the right hand side, end of a list, or if you are deleting from left hand side, beginning of a list. Sure. I'll draw an array here. Other operations we will see. Delete I have copied there. No, delete it as it is here. Okay. 0, 1, 2, 3, 4, 5, 6, 7. And the elements are 4, 6, 2, 9, 3, 7, 5. So we have finished insert, delete. Now we'll talk about find. This is a simple operation. Sure. Simple one. This searching means search, find, same or not? Same. They sound same. We use them as synonym. finding or searching, we can take it same. Okay. Or I have another word, get. Get or search same. What is get? So let us call it as get instead of find. You can use any word. See, find who is there at the door. Door is the location. Who is there, we don't know. We don't know the element, we know the location. Find who is there at index 4. So we know the location, we don't know the element. Right? The find where is, sorry, I am saying find where is 9. So actually it's not find. Search where is 9. Search where is 9. So we want to find his location. Alright. Search where is student Raj. So we know the person, but we don't know where he is. We want his location. So one thing is, you know the location, but don't know the element. Other one is, you know the element, you don't know the location. Two things are there. Knowing the element, finding its location, or knowing the location, finding the element. Two different things, right? So when you talk about any element, there are two things involved, element itself and the location. Now when you know the location, you want to know the element, that you can call it as get or find. Get or find. So let us say find or get. They are same thing. So for this, again, what you need? Index. Let us say index is 4. I want to get an element from index 4. So it's simple. Just say 𝐂𝐸𝐴𝑠𝑖GN. If it is valid, you should check that it is valid index or not. Within this range only, right? Otherwise, you should not give the element. Get the element, that's all. And just I'm adding one more line instead of simple line. I'm adding one more, return X. So what's the time taken for finding or getting? Order of 1. Order of 1. So find or get, you can take the heading, find or get. Just, we know the index, we want the element. Getting or finding is getting an element at a given index. Getting an element at a given index. Access, no, commonly the term used in data structure is get. You have built-in data structures like yesterday I was discussing in Java and C++ you have. So you have get for getting an element. Get or find. You can use any word here. So this takes constant time. Over. Now the next is Acha. One more thing is there which is not in the list. You have to answer this. I'll write something there. You have to answer. See here. Insert index X. Insert an element X at given index. Put index X. Put, not insert. Now what it does, don't know. But what the meaning it is giving to, I am asking. Put. Just changing the value, not shifting the elements. Not shifting the element. Put gives the sense there. Put it there. Put it there. Already something is there. We are not concerned about that. Just update. Like get means to get the element at a given index. Put means just blindly keep the element there. If already there also, just forget it and write on a new element there. So put give that idea. Alright. So why I'm showing you here is that mostly in built-in data structures, you have the operations like get and put. Get, put. This type of operation is there. Put, it will put the data there. So whatever the data was, it is lost and the new data is written. So it is overwriting. Insert means making a space and adding it. Otherwise, put means what? Just overwriting. Overwriting it. Now we'll go on to the next one. That is search. Search. How many type of search are there? Two type of search are there. One is linear search, other one is binary search. Linear search and binary search. Linear search. So first we'll talk about linear search. Watch it here. Search means you know the element and you want to find out where it is. You want to know the location of an element. You already know the element. You want to know the location of an element. Suppose I want to search for an element 7. So usually we call it with a word called key. You are searching for a key 7. The thing that you are searching, the data that you are searching, we call it as a key. That's why in search engines you have keywords, key phrases, keyword. So here we have key number. Key is a number. So that you are searching is called as key. So I want to search for 7. So what is the procedure for searching for 7? Simply start from the first index, linear search. So you can go linearly and check, is it 7? If it is not 7, then just move this one to the next location. Is it 7? No. So then just move to the next location. Is it 7? No, this is not 7. Then move to the next location. Is it 7? No, this is not 7. Then move to the next location. Is it 7? No, just move to the next location. Is it 7? Yes, 7 is found. So just you have to go on moving to the element and checking whether it is 7. So this you are doing nothing but what? You are visiting all the elements. So this is same as traverse. So for traversing, you know very well that you have to use a for loop, right? So you have to use a for loop. I'll write it with white only. So for I assign 0, I is less than whatever the length of a list is, then I plus plus. Less than length means up to 6 it will go. So what you have to do every time? Check whether key is matching with A of I. If it is matching, then you got the result. Then you got the result. It is matching. So what is the result? We will get the result, that is I. Return I. That's it. See, wait a minute. Do we already know what the element we are searching? Yes. So what do you want? Element you want or where it is? Index you want? Index. That's why we are returning index. And if suppose you are searching for some element, let us say 10, which is not there. So if you are searching for it, then you have checked it's not 10, not 10, not 10. Up to here also you have checked this is not 10, this is also not 10. Then you will move here and stop. So you have stopped because you found the element or the list has finished. You have stopped because the list has finished. So you came out of the loop because the list has finished. Means the element is not found. So when the element is not found, usually we return -1. What is -1? See, the indices always start from 0 in an array. We know very well that. So we send some invalid index. So we return -1. Usually search algorithms, wherever you write search, whenever you write search, you return -1 if the key is not found. Now listen one thing. When we talk about searching, there are two possibilities. Search may be either successful or it may be unsuccessful. When you are searching, search may be either successful, search may be unsuccessful. Successful means the element is found, unsuccessful means element is not found. Alright? So this is linear search. So how linear search is done? Just by traversing an array from left to right, we check every element until the element is found or we have reached the end of an array. This is the piece of code. All right. So I'm just writing a piece of code. I am not writing a function or a complete program. There is no gate question on these topics. No gate question. Yesterday what I covered, there were 3 previous gate questions. Very good question. Very good question. Searching can be done only if you have a unique list of elements. Searching can be done only if you have a unique list of elements. All right. This search, basic search. If you want to find all occurrences, then just finding occurrences of an element. So in Google search, when you search, you will not get just one list, one link. You will get all the links wherever it is found. So it's showing all the occurrences. All the occurrences. But still we say search engine. Search engine. So it is finding all the occurrences of that particular element. So if there are duplicates, you may have to find all the elements. You cannot stop on the first one. So that is a different algorithm. Find all occurrences. So you have to know all the indices, not just one index. So this linear search, when we say searching, means it can be searched in unique elements. And we get only one index. All right, only one index. If there are duplicate, we cannot stop on the first one. Okay. If you stop on second one, no, I wanted first one. Then which one you want? So we will give all. Take all of them. So that's a different situation. Now you have to tell me what is the time taken for, what's the time taken for the searching? Minimum time? Minimum time is what? O of 1. When it is O of 1, case you tell me, the case is if you are searching for an element which is found at the first index itself, beginning itself, that is big O of 1. So time is order of 1. And the maximum time is you are searching for some element, by chance it's present on the last position. So, and where you are spending time here, see this loop is repeating what you are doing here. You are not printing, you are not shifting. What you are doing then here? Comparison. So the major time spent by a search algorithm is on comparison only. Major time spent by searching algorithm is major time spent by the searching algorithm is comparison only. So the number of, see, the time is measured in terms of number of comparisons done. Either one comparison or maximum n comparison. So what is average? Average, what do you have to do? All possible cases divided by number of cases Again, the analysis will be sum of first and natural number divided by n. So again, it is same as linear search, what we have done. So average time is also order of n. In case of successful search. Now one thing. What if the element is not there in the list? Whenever you're searching, element is not there in the list. Search is unsuccessful. So the time is O of n. Now one interesting thing here. In case of successful search, you have cases. In case of unsuccessful search, you don't have any cases. Minimum, maximum, average, nothing is there. So just one value is there, one element, one answer you have. So what do you call to that? If you have to give a case for that one, we call it as a average case. Actually, it's a worst case, but actually we call it as a average case. If you are always getting a same time, independent of anything, then we call it as average case time. All right. So for unsuccessful search, it's always 1. Order of n. Sudhir, if you want to insert once again, yes, you can insert. So that's the insert operation. Online student. It will be an insert operation. Yes. Adrija has given best case as 1. Order of yes, correct. For search, yes. Achha. Now you tell me one thing. All these things you know, or are you learning something new? Something new. Something you know already. हाँ वही है. तो एक्चुअल गेट कोचिंग में मेरा अप्रोच ये है कि वही डिस्कस करो जो सिर्फ न्यू है. बच्चों की तरह हर चीज समझाना जरूरी नहीं है. वी अज्यूम दैट बिकॉज वी आर नॉट टीचिंग. I'll be not teaching, or nobody will teach how to write complete program. So you are not doing programming. So this can be done quickly also. But I am writing the code. है ना? तो ताकि कोई क्वेश्चंस ना आए, डाउट्स ना आए. So you should not get any doubts at all. So I am taking into detail. So it may become boring again. ये भी हो सकता है ना. अरे उसको पता है, असल बात बोलो. असल कब बोलोगे असल बात? तो यहाँ पे गेट क्वेश्चंस बहुत कम टॉपिक में है इसमें. लाइक इन रिवर्स यू हैव sorting is a very big topic. We'll cover it separately. I'll not show sorting right now. There are many sorts are there. So we'll cover all of them later on. When we complete merge sorts, that is quick sort and heap sort, that time I'll cover it. Oh, सारे sort एक साथ. यानी we will cover bigger sorts first, then we'll come on to the smaller, simple sorts. Okay, because you have different type of questions on sort. Many questions are there on sortings. And tricky questions can be framed on sorting. So that is a separate topic. I will not mix here. Anyway, in reverse part and also some rotation operation also there that I will discuss, on which gate questions are there. So this is insert delete. So what we have learned in this is what? The time complexity. What is best case? What is worst case? What is average case? Case means different thing, and the time complexity is a different thing. All right. And if you observe, when we were finding average time, we got the answer as what? N plus 1 by 2. We got it like this. This is nothing but a polynomial. Hey. Now I'll tell you something new. That you don't know. We get the time complexity usually in polynomial or exponential. Okay? Why? Why not any other form? Polynomial or exponential? Why not in any other form? Integration also possible. Differentiation also possible. We can write different type of mathematical expressions, equations. But we prefer only polynomial equation or exponential equation, because that gives the idea about the behavior of the algorithm. We get the idea about the behavior. It's linear, it's quadratic, it's cubic. We get the idea. Oh, cubic, it's bigger. Linear, simple. Constant, oh, simple, very simple. So just we get this idea. है हाँ ठीक है. For example, if you ask me, sir, how far is you want to visit some place, how far is tank band? तो ऐसे सीधा चले जाओ, उसके बाद लेफ्ट लो, उसके बाद ऐसा जाओ वैसा जाओ, इधर से फिर थोड़ा स्ट्रेट जाना पड़े. सर कितना दूर है ये बोलो बस. बहुत दूर है. हाँ बस है, ठीक है. दैट्स व्हाट यू वांट आंसर. गॉट इट. तो सर एलबी नगर जाना है, ऐसा जाओ ऐसा जाओ. सर कितना दूर है ये बोलो, पास में ही है. दैट्स व्हाट यू वांट द आंसर. So we want the answer. Time complexity doesn't mean we want to go in all the details. We want to simplify the complexity. Simplify that complex thing. ऐसा जाओ ऐसा जाओ, कितना है, पास में ही है, अब थोड़ा दूर है, अब बहुत ज्यादा दूर है. We want the answer in this form only. All right. So that's what the easiest thing is, polynomial. Polynomial. Otherwise, exponential also gives the idea to us. So it's exponent or it's power of something bigger. All right. So that also gives some idea. Understood this one? So we can easily visualize or understand these things, these two things. See, if I say, ये कितने में पड़ेगा? अरे बहुत महंगा है. ओ रहने दो. That's all. We stop. We don't want to know what is the exact price. कैलकुलेट, रुको मैं कैलकुलेट करता हूं. नहीं रहने दो यार, महंगा है ना, छोड़ दो. अरे बहुत सस्ता है. हाँ अरे देख तो लो टैग, अरे कुछ नहीं ले लो, अब लाओ दे दो. सस्ता है बोल दिया ना, तो विल टेक आउट मनी, जस्ट गिव इट. हाँ एक मिनट. At 8:30 I'll stop. 8:30 I'll stop today. half an hour, yeah. 8:30 I'll stop. बारिश हो रहा था, that's why I'm late. I have to throw my bike somewhere and came by auto. So it was raining. So I have to pick up the bike. हाँ नहीं यूनिकॉर्न नहीं है, हाइनेस टीवी. Okay, so for when I say it's very cheaper, then we'll take out. देख तो लो, 500 होंगे भाई, बहुत हो गया, चलो. So just you need the idea. Costly, cheaper, average. In this way, we give the time complexity. Order of 1, very fast. Order of n, little slow. N square, it's little more than that. N cube, it's very costly. So that's what the idea you want. That's why we remove everything and we take that highest degree term. Understood this one? Understood this one? Understood this one? Got it? Suppose you have analyzed, listen carefully. I'm giving you the idea of this one, just the idea, okay? Not a problem to solve, just the idea, main concept I'm giving you. Suppose you have analyzed the time complexity of some algorithm and you got the function as is it polynomial? Not a polynomial. It's a integration. You need to convert it into polynomial. Then get the answer. All right. For every integration, do you get the exact polynomial? For every integration, you will not get. So usually integrations are approximations. Approximation. Yes or no? All right. So actually your time function is in the form of integration, not a polynomial. You have to convert into polynomial, but you are unable to do it perfectly, or you don't want to do it perfectly. So what you take? You take nearest polynomial. If you are taking the upper polynomial, or you may be taking the nearest smaller polynomial. If you are taking upper polynomial, higher polynomial, you say big O. If you are taking lower polynomial, then you take ओमेगा। नहीं नहीं, जस्ट लिखा में, इसका आंसर नहीं चाहिए, वी डोंट वांट आंसर। आई एम राइटिंग इन टर्म्स ऑफ एन। आई एम सेइंग दैट for some mathematical expressions, I am saying that for some mathematical expression, we cannot convert them into polynomial perfectly. So what we take? Either the higher polynomial or lower polynomial. So that is upper bound or lower bound. If you are taking upper bound, you say, no, if you are taking upper bound, we say big O. If you are taking lower bound, you say omega. आ गया, आइडिया आ गया, ओमेगा बिगो क्या है, समझ गए नहीं समझ गए है? अच्छा, टिल नाउ टुडे व्हाट ऑल द टाइम कॉम्प्लेक्सिटीज यू फाउंड, हैव यू केम अक्रॉस दिस टाइप ऑफ सिचुएशन डिफिकल्टी और वाज इट इजी टू फाइंड अ पॉलिनोमियल? So whatever the polynomial you got, whether you call it big O also same, whether you call it as omega also it is same. So big O omega is not best case or worst case. Big O omega is the upper bound of a function or a lower bound of a function. This is for the mathematicians. This is for the mathematician. You take the upper bound. If they are unable to solve, if they have to take the approximation, they can take the upper bound or they can take the lower bound. And there are some functions for which we will also come across, for which we cannot decide, so we have to take the upper bound. So we'll come across that. All right. So just for explanation, I have written something. Assume that we cannot solve it. So, आ गया idea आ गया. Now you know what is big omega. All right. Acha. If you are getting it perfectly, then it is. So actually, what all we are finding are nothing but theta. Theta. Direct answer we got now. That is theta. So one more thing. Big O is not bigger, bigger or equal. Omega is smaller or equal. So for equal also you can say omega. Is it clear? For equal you can say omega also, big O also. So till now we were writing big O of, we can also say big O of, we can also say theta of, we can also say omega of. Because we are directly getting functions. You will come across some situations where you cannot solve it and get a polynomial. So then we'll say roughly it is big O. That time big O is very much meaningful. Otherwise you say big O also, omega also, theta also same. This is a rare situation. It's not a common situation where you really need big O, omega and theta. But when you, in algorithms and programming, when it comes to mathematics, there are many situations. हम क्या टाइम ला रहे हैं? टाइम कॉम्प्लेक्सिटीज की बात हो रही है, टाइम वाली बात हो रही है, नॉट जस्ट मैथमेटिक्स, द कंप्लीट मैथमेटिक्स. We are limited to our algorithms only. So in this, we don't always need that big O, omega and theta. But like mathematicians has developed this topic, so they have introduced big O, omega and theta. आ गया, समझ में आ गया? Understood this one? That's all. So I have just discussed something new, which you don't have to note down, just you have to remember it always. Now we have finished linear search. Delete. Sure. Now next is binaries. Okay. Binary search. Binary search. Suppose you have an array. I'm just drawing it. I have the elements here. We are looking at another search method that is called as binary search. And for performing binary search, the list of elements must be already sorted. Already sorted. Now the size of an array is 9 and the length of a list is also 9. I have not left any empty places. I wanted to show you insert, so that's why I have kept empty place there. Right? So now I have taken full array. So for performing binary search, the list must be already sorted. So let us see how binary search works. Suppose you are searching for a key element, let us say 16. You want to search for a key element 16. So the procedure for searching is, see, when they are already sorted, suppose you have a book, suppose this is a textbook. All right. Suppose this is a textbook. Textbook is having numbers, page numbers. Page numbers are sorted or not? Suppose this book is of 200 pages. I want to go on page number 175. So how I should go? Linear search? Shall I do it like this, page by page? Or how we go randomly, just we open it from somewhere here. Page number 110. So which side I should go now? I should go on right side. I'll again go in the middle. I'll just open it. Yeah, this is 180. I should go on left side. Okay, now if I open, this is 165. 165. So where I should go? Right side, but not including that portion which I have already skipped. Right? So in between here, yeah, 175. So because there were page numbers and that are all sorted, so we can quickly reach on page number 175. Right? I don't have to scan through all the pages one by one. I don't need linear search. I can follow this method, that is nothing but binary search. So let us follow the same method here. How we look for a particular page or search for a particular page in the textbook. Same method will follow here. Similar method. So what we'll do is, for searching a key element 16, we will take two indices, low in the beginning of this array and the high at the last element in an array. We'll take low and high. Low and high. So low is at 0 and high is at index length minus 1. Wait a minute, let me explain this. Now we calculate low and high. We calculate mid. This is 0 and this is 8. We calculate mid. Mid is what? 0 plus 8 by 2 is, that is 4. So we check at the index 4 what the element is. Mid. It is what? 15. Element is not the one that we are searching for. So the key is, the value there is 15. So the key is greater than that one or smaller than that one. Greater. So we should search on which side? Right hand side. So when we have to search on the right hand side, just we will move this low to mid plus 1, because middle element already we have checked it, we don't need it, we can just discard it. We should make it as mid plus 1. So here I have to make this low as mid plus 1, that is 5, and high remains there only. High remains there only, right? Now once again calculate mid. 5 plus 8 by 2, that is 13 by 2. 13 by 2 is how much? 6. Integer division. Integer division. So take this mid to 6. Index 6. So if you go on 6, is it the element that you are searching for? No, this is not the element. That is 17. So our key element is smaller than that. It is on the left hand side. Key element is smaller than that, so it's on the left hand side. So what I should change now? I should change this high to where? Mid or mid minus 1? Mid minus 1. Mid minus 1. So now I will just remove mid from here. So high is a change to mid minus 1. So this is 5 only, and this is what? 6 minus 1. 6 minus 1. So this is 5. Now they are equal. Shall I continue searching or stop? Continue. They are equal. Yes, even if they are equal, I should continue searching. So this is 5 plus 5 by 2 is what? 5 only. So mid is also at the same place. Now if you check at A of mid, yes, this is the key element that we are searching for. Yes, it is found. So total how many comparison I got this element? 1, 2, 3 comparison I got the element. So if the element is smaller, key element is smaller, I am checking on the left side. If it is larger, I am keep checking on the right hand side. If I perform linear search, total how many comparison requires for searching for this element? Total 16 to reach 16, total 6 comparisons required. But with binary search, I was able to do just with 3 comparison. So why it is called as binary search? Because whatever the size of the list is, I am always checking in the middle, that is half of the list, half, right? If it is greater, then I am checking in another half, on the right half. Again, if it is smaller or greater, I am checking in under its half. So every time, whatever the list was, I have divided the list by 2, again by 2, again by 2, again by 2. So in this way, I am keep on searching. So by 2, 2 means binary, right? So now you tell me how much time this is taking. Log n. So n is by 2, by 2, by 2. In this fashion, it's checking. So successive division is nothing but what? So you can, successive division is what? Log. Successive multiplication is power. Successive division is log n. So the time taken by this procedure is nothing but log n. All right. So let me take one more. I'll take one more. This was for what? Key is equals to key equal to 16. Now let us take another element and check it. I want to search for a key element, that is 10. 10 I will take. I'll take the key element as 10. I'll take the key element as 10. So let us try once again. Low, high and mid. See, 10 is not there. So I want to know how to write on the algorithm, how it behaves, or in how many comparison it will give you the answer. So low and high. Low is here and high is at 8. So this is low and this is high. Now first of all, find out mid. 0 plus 8 is by 2 is how much? 4. See, for same low and high, always I get same mid only. Same mid only in the list. So this is mid. Is it the element that you are searching for? No, you are searching for 10. Your element is smaller. So what you should change? You should change high and make it as mid minus 1, because you should search on the left hand side. So this remains 0 only, and this becomes what? 3. This becomes 3. Now again find out mid. Mid is what? 0 plus 3 by 2 is what? 1. So now mid is 1. Array. Mid is 1. Mid is 1. Now check, is it the element that you are searching? Is it the element that you are searching? No. So you are searching for 10, but this is 5. So 10 is greater than this one. So you should search on which side? Right hand side. So move low to mid plus 1. So low will change to 2 and high remains 3. Now you find out mid once again. So this will be what? 2. So new mid is what? 2. New mid is 2. Mid is 2. Now at mid, A of mid, you check whether this is the element that you are searching. No, it's 8. My element is 10. So my element is greater than this one. So what I should change now? Low. Low should become what? Mid plus 1, right? Low should become mid plus 1. So this is 3. and this is remaining 3 only. So low will move to the next location. So this was new mid. So what is the new mid now? 3 plus 3 by 2 is how much? 3 once again. 3 once again. So this is new mid. This is new mid at 3 only. Check. Is it the element that you are searching for? No. 12 is not the element. So then where my element is? Element is on the left hand side. So if it's on the left hand side, what you should move? You should decrement high to mid minus 1. So if you decrement high to mid minus 1, so low remains as it is. High is how much? 2. Now, shall we continue further? No. Why? Because low became greater than high. If low becomes greater than high, stop and say that element is not found. Here you don't continue and say element is not found. When low becomes greater than high or high becomes smaller than low, then stop and say the element is not found. Is it clear? So I have shown you one example of successful search, another example of unsuccessful search. You can take this tracing. You can take this tracing. See, we are going in detail of the tracing, every step we are going through. So the question can be, how many comparisons are done if a particular element is searched? All right, this is possible. Yeah, log n base 2, Adija. Online students, yes. We are learning how to trace the procedure. So code is not there. We are not tracing the code. We know it's working. So just we are tracing it based on its working. So tracing is useful because in GATE questions, you may have to do this one. He will give you a challenge or he will give you a question. For that, you need to understand it and trace it, then give the answer. Maybe in words he is explaining. So understanding the thing thoroughly by tracing it. This is important in this one. High इधर आ जाता. High becomes smaller than low. Low becomes greater than high. होता फिर से वही होता. Log n मतलब वो देखेंगे. Let us write the algorithm here. Let us write on the algorithm, just a piece of code for performing binary search. So whatever the key is given. Let us take some key here, whatever the key is given. First, low should be at 0 and high should be at low should be at 0 and high should be at length minus 1. No main function, no separate function, just a piece of code, right? Now, what you have to do? And every step you have to calculate mid, that is mid is equals to low plus high divided by 2. So this is going to be a floor division or seal division. Floor or not? Floor. So this is floor division. So if I make it as a pseudo code, I can write it like this. But if it is a C language, it's understood if both low and high are integer. If they are floats, then things are different. So if by putting this one, it means that we want floor value we want. Means no decimal part. Alright. So this becomes a pseudocode now. So we'll find out mid and check if key is found at A of mid. Is it at A of mid? If yes, then just return the index of the element found. The index is what? Mid. If not, then else. What could be the possibility? Else. What could be the possibility? If key is less than A of mid, if it is less than A of mid, then what you should do? I've taken bigger size actually. If it is less, then what I should change? I should search on the left hand side. So what I should modify? High should become mid minus 1. Else, if it is not equal, if it is not less, definitely it is greater. So I should search on the right hand side. So what I should modify? Low is equals to mid plus 1. And I should keep on doing this. So repeatedly I should do this. So this should go inside a loop. And how long I should continue this one? As long as low is less than and equal to high. When it's equal to also, I should check it, right? When the low is becoming greater than high, I should stop. Greater than high, I should stop. So if suppose the key is not found, then what I should return? So if suppose the key was found, I would have, if key was found, if key was found, I would have returned from here itself. If key is not found, means I came out of the loop, then I should return what? Minus 1. This is the code. Alright. So you are familiar with the code. So hold on. Don't copy it. Okay. Let me explain few more things. Let us do some analysis. For this particular example list, look at this. We are doing analysis. All right. So for this example only we do analysis, not general analysis. From that we'll get the idea of general analysis. Whenever I am finding mid of this one, I am always getting index what? 4. I will write on the index here. All right. Or shall I write down the element 15 here? I'll write down 15 here. Okay. This is the first mid. Watch this. I am doing analysis. If I am see, actually you are learning how to do analysis. All right. How to do analysis, that you are learning. If any task is given, you should be able to think over it and analyze it. With minimum steps, you should get the answer. So, but for that, you need to practice first. So that's what you are doing. Now we want to find out actually what is the time taken by binary search. So just I gave you the idea that it is successively dividing. So we got it as log n. Okay. That's one way. Now other way, let us analyze it thoroughly. So whenever you are getting a mid, it's here. Now if suppose the element is smaller, then you will check on this side. So what is the mid you will get from here now? 0 plus 3 by 2, how much? 1. So this is the second mid you are getting on this side. So this is element 5. You will be voting on element 5 every time, whichever element you are searching. Now, if suppose you are going on the right hand side, so 5 plus 8 2. So how much this is? 5 plus 8? 13 by 2, that is 6. So this is the second mid you get on this side. So the element is what? 17. So now you tell me, if you are searching 17, in how many comparisons you will find it? No. If you are searching 17, in how many comparisons you will find it? 2. If you are searching 5, in how many comparisons you will find it? 2. Now for the left hand side of this one is just 3. So for 5, left hand side is 3. But on the right hand side, so this is third mid, you can say third mid. Now in between this, what is the mid? 2 plus 3 by 2. 2. So this is the third one at third level, right? So 1, 2, 3, third level, 8. Now only what is remaining now? 12. So it comes on which side? Right side of this one. Right side of this one. Following or not? Now in this list we have taken this. Now it's audible. See, for when I am finding mid out of these elements, for these elements, the first mid what I'll get is here at index 4, so the element is 15. Then if the element is smaller, I'll search here, so I'll find out mid that will be at 2. So that is 0 plus 3 by 2, that is 3 at index 2. So that's how the element is, 2 at index Sorry, just a minute. If I am searching, if I am searching on the left hand side, then 0 plus 3 by 2, that is 1. So the index will be 1. So here, this is the second element I get. In the same way, on the right hand side, 17. So I have generated a tree for this one. So for all successful search, I have a that are represented in circular nodes. And if you are searching for any element that is smaller than 3, your search ends here. You will not be checking, but it ends here. And if you are searching for any element in between 3 and 5, it ends here. Searching for any element that is greater than 22, it ends here. So a square nodes represents unsuccessful search where the comparison is not done. Now you have to answer it. What is the maximum number of comparisons required if there is unsuccessful search? Just think and answer. Think and then I am repeating many times. I repeated something many times. What are the maximum number of comparisons required for unsuccessful search? 4. I am saying that this is representing unsuccessful search, but the comparison is not done. You will end up here. That is just representing them. हो गया, यहाँ तक हो गया, समझ में आ गया? Understood this one? Got it? So we have represented how its behavior in the form of a tree. Now, if you know which type of tree this is, remove square nodes. Binary search tree. Yes. Understood this one? Now, height of a binary tree is how much? How do you represent? Log? Log n. Right now we have not covered it, but when we cover it, so it's default now. I don't have to explain what is log n and all. Right now I don't have to explain. Just you have to accept it, because we'll understand how it is log n later on. Okay. So let us write it as log n. हो गया, यहाँ तक हो गया. Understood? Now one important thing is coming. How many elements are there? 9. Log 9 base 2, how much? 3 point something. 3.12. Okay. This is maximum time you are saying or minimum time? Come on. Maximum time you are saying. Minimum is 1 only. Just middle of the list. Maximum you are saying height of a tree. Height of a tree is commonly known as log n. So I wrote log n. So for 9 I found out it's 3 point something. So seal or floor? Seal. So if you want exact answer, it's seal of log n. If you want rough answer, means asymptotic answer, it's O of log n. If you want exact number of comparisons, then seal of log n. Understood this one? If you don't want exact comparison, just the idea we want, O of log n. So two different things. All right? Seal comparisons are required, not floor. Seal comparisons are required. So on this point also gate questions are there, whether it is seal or floor. So you have to trace it, not the same thing, something different, some different question. In that you should trace it and find out whether it is floor or seal. Understood? So he will say, count how many comparisons are. There is a question. It was actually included in C programming question. If you have that sheet, you can check it. Total how many comparisons are required in this loop. So that may belong to data structure or algorithms, you can say. So floor, seal, or +1, -1, something is given. You can check that. Yeah, it means you have not checked that PDF. It was given in one of the lecture, na? You can go through it. I have given you all the questions in last lecture, right? And that you can check, huh? Get 6. अच्छा, आंसर बोल रहे हैं हम. Now audible? Now this is the height of a tree. Height of a tree is log n. So that's how we have log n number of comparisons required, log n number of comparisons required. And we have, here we realize that it's not floor value, it's a seal value. Like log 9 is 3 point something, so it's not 3 comparison, we know it's 4 comparison. So it is seal of log n. Seal of log n. हो गया? So we have analyzed binary search and we got the time as log n. That is the maximum time. And maximum time, minimum time is 1. An unsuccessful search always log n. Unsuccessful search always log n. All right. So that's all. We'll stop here. In the next session, we'll continue from here. We have a few operations like this. We will learn few more operations. Then we have matrices topics and topic under. Some gate questions were asked from matrices also. 2-dimensional array.